Well, one of the things we're going to need for this project is some CAD files, a computer-aided design file showing all the stuff. We'll need this in order to build the case. Have all the exact measurements, everything sized correctly. We saw the import the PCB, and I have some other components that I've just downloaded from either manufacturer sites or community source libraries online. And we can have a lot of them, but I don't quite have all of them. For example, I don't have a nano in uh, that I can just copy over and put in here. So I'll need to download that or sit down and draw it. And that can be kind of fun. Sit down with calipers, micrometers, rulers, and just all manner of measuring devices and put that together, put a virtual model of it together that is an exact replica of the physical model. Can be kind of fun, very time consuming. Or, well, since we're measuring a nano, might as well throw out for measuring devices. Hook up some ultrasonic range finders or laser distance things and get our measurements from, have a device that gives us exact measurements. Then we could just copy and paste the numbers over to get the model built, which seems like it would be a fun little project in itself. But there's a whole lot of things already built, and we can go to community source pages and just download some files. And I bet there's a nano already on there that we can just download the files from and use that in our project. So let's go look and see if we can find a nano. And as far as going over the steps of doing CAD, we'll do that. We'll go over the steps for making the case, because that'll be a much easier thing to make than say designing a model of a nano. That will be a little complicated, but a case won't be too bad. So we'll go over the steps there. So first off, let's go see if we can find a completed version already to just throw into our project. And one of the best places to look is you can go right to the manufacturer site and look there, because obviously that's good for selling their product if it's used in the virtual model in our modern world. So you can go to a lot of manufacturers and download right from there. Lately, I've been going to this site, grabcad.com. It's free to set up an account, and this is just a community source library where people share CAD files. So you can download things other people have put on there, or if you have some models that you're very proud of, you can upload that. So we can just go to the library and search for nano. I'll look for Arduino Nano. And there should be some results. Yeah, there's a couple. So there's one. It looks similar. This shape is on the bottom on mine, so wouldn't quite match that. This one might work. If we scroll through here, you can see there's quite a few. And I'll be doing the CAD stuff in Blender, and it's unlikely there's going to be a Blender one here. But there are ways we can convert the file over. So this has an STL. That's probably the best way to convert the files. STL stands for stereolithography, though lately a lot of people have just started calling that standard triangle. All of the polygons are reformatted as triangles, so pretty much any 3D modeling software can deal with the mesh then. So there's a lot of step files. I believe that's SolidWorks, Fusion 360, Inventor. So a lot of parametric solid modeling files on here, really. But I just need a mesh to work with in Blender, so I can download that and convert it to an STL mesh on any of these. Because this one has an STL, but it doesn't have any pins connected. And you can see there's lots of pages of results. You can kind of dig through there, find the one you want. I'm just going to go with this one here at the beginning. Has most of the pins. It doesn't have these 6, which aren't used in the project, but they are connected in the board I'm going to use on the project. I went ahead and soldered those up already. But I have some pins. I already have header pins that I can insert in there that are the right size and everything. So I'll go ahead and download this one. And we can see the different images. So the boards I'm using have the square chip on top. and the rectangle chip on the bottom, rectangle chips. So this looks like an exact match of the ones I have. I have a white reset button, but we can change the colors on that later. So I'm going to go ahead and download this. And it looks like this has a bunch of images of just pictures of the things, and down here is the step file. So there's I think step is from SolidWorks. But once we get that, we can just download that file, which a step file is not one that Blender can import. So we'll have to modify that. And that's this other tab I have open here, Freecad. Freecad is an open source parametric modeling software. So open source, so it's free. It takes Python scripting. That's one thing I really like about it. Blender also takes Python scripts, so I can often convert this, use the same scripts in both of them. For video games, I use Blender, which is more animation software. And really nice animations, 3D animation software can handle engineering type CAD. But engineering type CAD doesn't quite work so well for really nice 3D animations for video games. So Blender's fresh on my mind, and I tend to forget all the keyboard shortcuts and things in FreeCAD. But those are the two I use most often. But like most open source products, sorry about that, it will recognize most of the standard file types from the standards in the field, including the SolidWorks file. So we can open that step file in FreeCAD and then just export a stereolithography mesh from that. So let's go open up FreeCAD and do that. So here we are over in FreeCAD, which obviously it's parametric modeling software. So this would be a better place to do a model like what we're doing. I just use Blender because of video game animations. Blender stays more fresh on my mind, and I tend to forget all the keyboard shortcuts and stuff over here. And over the years, I've set up various scripts, and I have a number of scripts that'll take a mesh from Blender, which Blender also has a nice physics engine, so we can do a lot of simulations and stuff there as well. But I have scripts that will take a mesh from Blender and export that into something that can be imported into a parametric modeling software and just bring them back and forth if I need to. So for right now, I'm just going to use the actual CAD software to convert that model that we downloaded, parametric solid model, into a rendering mesh to work with in Blender. So if I go to File and Open, and you can just navigate to Downloads. Oh, it's already there, and open the one that we just downloaded, which might take a second, so I'm going to pause the video while that loads in, because it is a parametric modeling software, so not the fastest thing. So that didn't take too long, just about 45 seconds or so. You can see here it's parametric modeling, so all these components, all the pieces came in as separate things. We have a chip and all the connections, and somebody built all the pieces separately and put them together, which can be kind of fun. I enjoy doing it. It's just a little time consuming. Bring all the pins in, and then here's the just attachment. So what we're doing here over in Blender would probably be better done here, but I'll go ahead and do it in Blender because that's just what I'm more used to. So, and then if we need to come back to parametric modeling and examine all the components separately, we can just export it from Blender and bring it back in here. Export and import works both directions. So I'm going to export that. First off, we have to select which pieces to export. So we go to Edit and select all, because for some reason Control A doesn't select everything. I'm always confused every time I come across that. I wonder what the programmers were thinking when they decided that Control A should do something other than select all. But it's up here in the Edit menu, select all the parts. And with those selected, we can go to Export and change our file type to a stereolithography, or standard triangle, as it's kind of more commonly become known. So we'll just export it as that. which that goes through, combines it all into one piece, and converts all the polygons into triangles, which any 3D modeling software can handle. Any type of 3D modeling software can handle. So that's kind of the general exchange format that works everywhere. So I'll just call this Nano and save it there in the downloads folder. And once that's downloaded, we can close this and go back over to Blender. Go ahead and discard those changes. So here I am back over in Blender, new file. I'm just going to open a general file. And maybe what I like about this is the animation software has a lot more tools. There's a lot more tools to use to get the pieces together, and then those pieces can be exported and worked with in parametric modeling software later, or just use the physics engine here to run simulations and things. But for whatever reason, I kind of prefer to do the CAD work here instead of regular parametric modeling software. So that's what we'll go over in these videos. So here's the default setup. Obviously not going to need a camera for this or lighting. So I'm going to delete the default ones. And by default, it's set for a box setup select. I prefer the just freeform selection. So if you put your cursor anywhere in the middle and hit W, it'll scroll through the different selection types, and then the freeform selection will be especially important when we go to apply materials. So delete those things, then just File, Import, and a stereolithography file, and this is in Downloads. There it is. So that nano.stl that we just exported from Freecad. So you can see it's all just one solid piece mesh now. And we lost all the material data because over in the parametric modeling software, all the material data was saved to the piece. So we need to bring the materials in. But I happen to have a script I've collected over the years of doing projects like this that just a scripted version of creating materials. So I'm going to go grab that off the drive account and we'll run that real quick to get some materials to apply to this, to our nano board here. And might as well go ahead and grab those other 6 header pins. So I'm going to go grab those files off my drive account, which after the video editing is finished will only be a second from now. So download those files. So there's just a Python script. Let's take a look at that real quick. I'll open it with Sublime. Notepad++ has the notes for making the video right now. So just a little script to run in Blender with a bunch of materials, and this is the one with materials that I've used for the electronics stuff. So different colored PCB boards as they've shown up, or perf boards, some types of metal, and lots of plastics for casings. Just some materials that tend to show up in an electronics project, and that way they don't have to be recreated every time. I just put all of them in a script, and I'll just run this whole script over in Blender. And also header pins so that we can fill in those 6 holes. So I'll open this in Blender real quick. Hopefully it'll open quickly. It's not a super complicated file. Well, I'll pause while this opens. Oh, there it goes. So I have some header pins, and well, I don't see a double row that has 6 pins. So I'll put that together and actually copy that over. Because it might show up again. So every time one shows up, I just copy over create the exact one I need. So here's a solid mesh with 5 pins, or one with 8 pins, some angle pins. I'll just go, and we could copy 6 of these over one at a time and put in the nano, but I'll go ahead and construct a version with 6 pins just in case. That way it's around for other projects later if needed. But basically it's just a copy and paste thing at that point. I'll do it with 1 pin. So if we copy that and then come back over to this file and paste that in, And now we should be able to move it over into position, and that'll help to check if this is the right size. We can also grab the dimension tool, the measuring tool, and just kind of take a measurement. 17.746. So 17.7, that measurement matches what the calipers told us the nano was earlier. So looks like that's the right size. And when I bring over a header pin that I drew that I know is the exact right size, and see it fits right in that hole there. Let's look at the bottom. A little bit off, but it'll be okay because we're just putting the mesh together here. I think my header pin might be a little bit bigger than the holes they left there, but it looks like all the sizes will work correctly. And I'll just copy and paste and put 6 of those together and bring that over as one piece. So, but this, our STL mesh, which if we go to maybe go in edit mode, we can probably see all the edges. Yeah, so you can see all the polygons were converted to triangles, and that will work in any 3D modeling software. So what we have to do to get material data back in here, since in the parametric modeling software it was stored with the part, so like the USB connection had all the materials for it, and the chip had all the materials for it, and the pins had all the materials for that. So when we made one big single piece, we lost that material data. So we'll have to come through and select each face of the mesh and put material data back on it. A little time consuming, but I'll show the first couple steps in the video here. And I have that script of materials, so we can bring that in. So up here in our tabs, we can go over to scripting. And if you're familiar enough with CAD to just type stuff in, there's a Python interpreter here, and you can type the instructions right in. And to learn them, you'll notice this little section down here at the bottom. That shows everything we do. So like when we select something, there's it gives the exact thing of what we're doing. So if we select that and tried moving it, where are my little buttons? Make this a little bigger. Oh, there they are. Move that. And you can see here is the instruction for moving it. And that's a good way to learn what to type in the interpreter directly. Although it's probably a better idea to save it as a script. Undo that so it's still centered. Keep the origin where it was. So now we can go ahead and import this script. So come over here on the scripting tab, go to open, and I just downloaded that. So in my downloads folder is this create materials.py script that has just been building up over several projects. And the run button's hidden from that resizing, but a bunch of different materials that'll match electronics projects. So I can just run the script, and it brought in a bunch of materials. You can see down here, there's a long list of materials to choose from now. So PCB green is what's showing. The very top one here is the main one we're using, and my nanos have the blue PCBs. So I'll just switch that over to the blue PCB, and that you can see that brought in a long list of materials to use, some metals and plastics and different things like that. So we come back over to layout mode to work with this now. That's already been applied, and we can select the materials view to get a better idea of what it's going to look like. So materials view, that way it's not semi-transparent. You can see it just made everything that the material of a blue PCB board. So we need to change some of these. So what we need to do is go into, with it selected, and go to edit mode, and then just reassign the material for every single polygon face on here. And I'll kind of just get started here. So this is one place that I really like the freeform selection. So if we leave the cursor somewhere in the view port and push W, it'll switch between box and circle or freeform selection. And then we can just drag and define this the size we need, and then all it has to do with the freeform selection is just touch the thing. So right now it's set to select vertices. So with vertex, if we select every vertex that surrounds the face, it'll select that face. Or edges, but since we're recoloring by the face, it's probably easiest just to put it on face selection, and then all it has to do is this freeform selection just has to touch it. So we can just drag across, select a bunch of faces, and those are all part of the pin, so those need to be metal. So if we come back over to the materials tab here, right now they're PCB blue, so I want those to be metal, just metal. So I'll scroll through here. Metal raw one, that'll work. And then hit the assign button. So now those faces have been reassigned as a metal material. And then we can just keep doing that, select all the faces, assign metal raw. And everything that needs to be metal, just turn that into metal. So you can see the freeform selection tool can be kind of quick, because then we can just select a bunch of things at once and assign the new material to it. Everything behind there's metal as well, so select those. And it doesn't hurt to if it's going to be the same material, it doesn't hurt to like this was already metal, but I'm putting metal down here, so it doesn't hurt to reassign it. Doesn't matter if we give the computers a little bit extra work. I can't tell if it got the bottoms there or not. That might just be shading. It looks a little darker, so I'll go ahead and assign that again. But now all those pins should be represented as metal. So I'll go through and do that for every single face on here. You can see it's not a difficult process, just a little bit time consuming. So I need to do that for the nano and the joystick. And I'll just grab one of the nanos and reassign all the materials so that this matches it looks right when we go put it in the board. And then just copy and paste to put it into that final design. And there's no new, it's just those steps over and over again. CAD is very repetitive. So I'll go ahead and do that, and we'll get back to the videos with when all the pieces are ready to combine. And then we'll actually go over the steps to make a device or make a component on the casing for all of this, because that'll be a much easier thing to make than, say, this nano here. You can see that one probably took somebody quite a bit of time to make that to all the exact specifications and everything. Whereas a case will be a whole lot easier. We'll be able to do that quickly in a video, and then something like this is the same steps, just more of it, just a little time consuming, very repetitive. So yeah, so just select the things you want to change the material of. If you download a version, so download a model, and it doesn't really matter the type. You can change it to an STL file and import that to work with any 3D modeling software. So just bring in the STL file, select the faces you want to change the material of, and assign the new material of those faces. And lots and lots and lots of that, a repetitive step. So I'll go do all the repetitive steps, and then we'll be back for more videos.